I'm the upfront. I'm like super nervous because I just gave a bunch of different talks, and like they're all on different topics too. So I'm trying to like get my thoughts together. I'll tell you now, I'm like very informal as a speaker. I'm not the kind of type of person who's just like, I'm going to read off my slides. I like to kind of like move around and chat with folks. Yeah, my name is Santo. I'm currently at a nonprofit organization called AI for All, and I'll talk about what we do in a bit. And this talk is going to be about the social implications of artificial intelligence. This is going to be slightly different than a talk that you might hear at a traditional like engineering or like STEM course. A lot of what this talk will talk about covers things from the humanities, things from the social sciences, and it might be uncomfortable at times. I've had people actually walk out of my talk because some of these topics are somewhat contentious. So just giving you a heads up. Yeah. To even motivate that, I have a leading example. So when we talk about artificial intelligence, what might someone who's never heard of it before think about, right? What might they do? Hold on. Give me a second. I think it's not working. There it is. They might go on Google, and they might Google a robot, right? Robots might have something to do with AI. So they might put that into, let's say, Google image search and look at, well, what do robots look like? Yes. So they might look at these images, and they see all these pictures of, okay, maybe this is what AI is. What do y'all notice about these pictures? Curious. What pops out at you? What do you see? I hear a few things. Someone raise their hand and like shout it out. Yeah. The what? Yeah, it's a physical thing, right? There's a physical robot right there. Someone else? Anyone else? Yeah, right there. Yeah, they're anthropomorphic, so they look like humans, right? We think about them like humanoid things. What's something else? Something that's very glaring. Anyone can get it? I mean, it's the obvious one, right? I mean, people might say that's a joke, but no, like, most of these robots are white. Yeah, they're white robots. And you might think of that as like, okay, well, hold on, the white robots, and someone actually pointed out to me while I was giving a talk like a year ago, hold on, they're also mainly blue-eyed. Why are we making these robots in the image of humans, and it happens that most of them are white and blue-eyed, right? Whereas you might see a darker robot with red eyes and say, oh, that's an evil robot. But why? What leads to that, right? Why do we have these conceptions already built in, right? So when someone looks at Google and they say, okay, this is the first thing they're going to look at to understand robots, they already get this sort of bias. And it's being all slow. When I was giving this talk a while back, a paper actually came out right before one of my talks, and this paper was talking about how though we have racial biases towards each other, there's actually racial biases that we extend towards robots of different colors. And in particular, I'm going to read out this quote that's highlighted down here. They had a study where their study revealed that participants were, this is really important, quicker to shoot an armed black agent than an armed white agent, and simultaneously faster to refrain from shooting an unarmed white agent than an unarmed black agent, regardless of whether it was a human or a robot. Right? So we have all these racial biases that we have as a society, as humans, but that's not exempt from the world of robotics. We extend it into that space. So for a lot of my talk today, I'm going to be talking about how we can bring our biases into technology. Right. Here. So this really feeds into a lot of the questions that I ask. So for instance, I think a lot about what's the impact that technology has on a specific population, right? Whether that's black individuals, whether that's women, women of color, and what sorts of cultural ideas or assumptions influence the creation of technologies, right? Just like the robots, right? Why are they all white and blue-eyed? So I think a lot about these sorts of questions. This draws on disciplines such as computer science and artificial intelligence, of course, but it also draws on things that are more interdisciplinary, such as science, technology, and society studies, which is a great, fabulous major here. I love the department here that we're actually in right now. And that draws on a lot of different disciplines beyond just STEM. So, for instance, things like history, philosophy, sociology, anthropology, right? We might talk about in engineering school, engineering, tech, that's all that matters, right? Social sciences, whatever. But actually, they make a big difference in the technology that we create and how it affects the people who use that technology. And finally, I think a lot about the space called critical race theory, and this is something that I've been kind of researching into more ever since I graduated from actually here. Critical race theory is this idea of let's look at systems of oppression in society, right? Let's question why racism exists, right? Why these sorts of systemic barriers exist for different individuals. And using that framework to understand, well, does that extend to technology? Is technology really amplifying these sorts of oppressions that we have in society? So for the talk, I'm going to give a brief introduction to AI. I like to throw this word around, but it's good to have some concrete feeling of what it is. And then we'll go into the social implications. And the goals really are to come away with a sense of what artificial intelligence is, just at a high level, and then understand how AI can affect us and our communities, because it really has a lot of big and deep impacts on the world around us. A bit about me. So I really love to talk about my identities before my talks, just because I think identity really matters. Who's in the room really matters, and it really shapes what we make. So for me personally, I'm a queer person of color. My full name is Santo. The last name Santo is Southeast Asian, so I'm actually Indonesian. People always ask me that question. I grew up in California, and people are just like, wait, Santo, like that doesn't seem like an Asian last name. But it is Southeast Asian. I actually grew up in the Bay Area, born and raised. I'm currently working out in Oakland, California, and before that, for about 6 years, I was actually out here in Brooklyn, where, as alluded to, I was here at NYU Poly, or Camden, I should say. Yeah, so we changed the name since. But yeah, so I was a graduate from Camden 2016. I got my master's here in the CS department, as well as my undergraduate in computer engineering. So shout out to all the computer engineers in the room. Let's see. So currently I'm the education manager at an organization called AI for All. We're a nonprofit whose mission is to increase diversity and inclusion in AI. So it's no secret that there's a diversity crisis in the STEM field. Obviously this field, to be really, really blunt, right, is dominated by white and Asian men. Like I know this, I see this, I see this when I go to classrooms, and we're trying to fight that, right, because we want to make sure there is more diversity and inclusion, and it's not just like a continuing problem. So we do this by running primarily summer education programs for underrepresented high school students. Last summer in 2018, we're at 6 different universities across North America, and we had 148 students. I got to meet all of them. These are pictures from all 6 sites. I am somewhere in all of these pictures. It was a wild summer. I literally was traveling for just 2 months straight. And our kind of motto is, well, AI will change the world, but who will change AI? Right, AI is really everywhere around us right now, even in our pockets, right? We have Siri, we have Alexa, we have all of this technology that's using AI. But we have to think about who's making that AI. Are the creators of AI representatives of the people who are using it? And this year, so those are the 6 universities we're at last year. This year we're extending to 4 more. And right here in New York City, we have a program up in Columbia. And before I jump into actually talking about the AI, I always have to give shout-outs. The thing that I always talk about is I couldn't be here without my mentors. I couldn't be here without my professors, the people who really trusted in me, right? A lot of the work in AI isn't just solitary. It takes a team. It takes role models. So shout-out to, for instance, Dr. Sophia Noble, who really turned me on to the idea of using critical race theory to think about technology. But also shout-out to Dr. Mark Hicks, who really was the first person who showed me that we can look at the history of technology and the history of oppression and really analyze that, as well as Mar was actually one of the first queer professors in the CS space to really say, like, I see, right? I see the work that you're doing. And of course, the bottom 2, you might have seen them around. These are Dr. Lisa Hellerstein and Dr. Jonathan Bain. Dr. Lisa Hellerstein actually is the first person teaching machine learning. And she is a professor here at Camden. So if you can ever take her course, it's truly, truly amazing. She does great work, usually at the graduate level. But really, I wouldn't be here if it wasn't for Dr. Lisa Hellerstein. As well as Dr. Jonathan Bain, who works in actually this department. Like his office is like right behind the stage. And he was one who I did research with for a long time on the history and philosophy of science. Let me get all the way back here. So we're going to jump to a brief intro of AI. Who knows what this is? Who's seen this? Who can make a guess? What do you see in this photo? Yes?
Watson.
Watson, close. Not Watson, but owned by the same company. else? Anyone else? A bit older than Watson. Anyone? Hands. Yes. Yes, excellent. So this is IBM Deep Blue. And this is always like in an engineering room, like people like know what this is. I did this talk at a lot of different spaces, but it takes a while. But I'm really excited. So this is IBM Deep Blue. For those who don't know, this is one of the great examples of artificial intelligence in the history of the field. Back in 1997, Deep Blue defeated the world grandmaster at chess. So it was the first time when AI beat humans at this game that we thought it was so complex that a computer could never beat us at it, right? So this is an example of old AI. This is 97. Really, your cell phones probably run things that this whole giant tower runs. So this is really old. Examples of AI today, again, you can see these, Google Home, Alexa, Siri. These are really everywhere. These are examples of AI. When you talk to Siri, when it listens to what you're saying, when it figures out what to search up and how to respond, that's all AI. Kind of on the verge of where we're going right now in the future. We have self-driving cars, of course. A lot of this uses AI to figure out where to drive, how to drive. Yes, and then even this, right? Even something that you might not expect is AI, Snapchat, right? In order to have the filters on your face, to detect even where your face is, that requires a lot of AI. And even 10 years ago, this was a really difficult challenge. If you told someone 10 years ago, right, we'd have this social media app where you put filters on your face, people would be like, that's impossible. That's not, you can't do that with technology. But here we are, and everyone's using it, right? So it really is everywhere. Now, I've been talking a lot about AI, but what does that mean? How do I define that? What's the meaning behind these words? Well, it turns out if you actually walk into a room of AI experts, you might get a different definition from everyone. So this is actually an excerpt from a really awesome small book called AI Pattern Language. And this is actually published by the Data and Society Institute up in Midtown. But really, they went to poll a bunch of different AI professionals, AI researchers, to ask them how they define AI. And no one really truly agrees, but we can make some good assumptions. We can generalize pretty well. For instance, AI, the way that we define that in our organization is it's a branch of computer science that allows computers to make predictions and decisions to solve tasks. Again, very, very general, very broad. This encompasses a lot of different things. So we take a step back. We think about, well, where did this field actually come from, right? Where did we start using this term? And to make it a bit more concrete, back in 1950, a man named Alan Turing came up with something called Turing test. Who knows who Alan Turing is? I just want to see. So who was he? Someone shout it out.
The guy from the movie.
Yes, the guy from the movie. That is amazing. That's exactly right. Do you know who plays him in the movie? Hey, there you go. All right, and no one said a pun on his name either, so I'm disappointed. No, yes, Alan Turing was a British mathematician who helped really crack the German codes, really helped the Allies defeat Germany in World War II. So really, really, truly big figure. There's a lot in the history of how that happened. He was a gay man. A lot of people who worked with him to crack the codes were all women. Lost the history. If you watch Imitation Game, the movie, right, you don't see any of the women code breakers that are with him, right? But they were really the ones doing the work. But yeah, so in 1950, after the war, he thought about, well, what about machines that can think, right? Could a machine think? And he created this thing called the Turing test to say, well, if they pass this Turing test, then maybe we can call it something intelligent, like humans are. So the Turing test, and I usually ask this, but I'm also a bit short on time, but the Turing test, I'll explain it, is imagine you are a human person at a computer, and you're messaging two different entities, and you don't know who they are. One is an actual person, and one is a computer. And you're just messaging them, right? The Turing test says, if the computer can convince you that it's the human, then it has reached a level of intelligence that's equal to ours or greater, right? That's artificial intelligence. If it can just convince you it's human. So that's the Turing test. Well, that definition is simple enough, but in 1980, a philosopher actually named John Searle kind of created a counter-argument to this. He said, well, that seems sneaky. There's something there that I think we're missing, right? If you can just trick someone to say a computer is a human, is that really enough? So he created this thing called a thought experiment called the Chinese room, where you can imagine there's a room, right? And within this room, there's a person who doesn't understand the language Chinese, but with him in the room is a book. And he can look at this book, and this book has a lot of Chinese phrases that translate, or that connect to other Chinese phrases. If you get a certain phrase, write something on a piece of paper and send back out this other phrase, right? So it's really input-output. And let's say outside, you have people who are writing Chinese, and they pass in this note. And inside, the person takes it, looks at the book, writes a response, and passes it back out. The person outside gets it and says, oh, cool, like this is a legitimate response. The person inside the room must then understand Chinese, right? So we think about that, and we think about the Turing test. His argument was to say that even if a computer takes in inputs, right, and responds with some output, and we see that and we think, oh, this person must be human. Do they really understand, does this computer really understand what it said to us, right? Does it have the level of kind of consciousness and understanding that humans do? So Cyril says no. Cyril says that's not AI, we have to think about something deeper. There's a deeper quality about it. And there are a lot of other definitions that have been proposed or rejected over the years. So one definition you might hear is giving computers intelligence, right? People say, what's AI? It's just computers with intelligence. Okay, well, how did you define intelligence, right? I told you what's AI, what's artificial intelligence, and you said intelligence. Doesn't really help me. The second one is giving computers consciousness. Some people think about it this way. A lot of people in the field right now don't really care about this. Like, if you can make a self-driving car drive down the road and like figure out how to like get you from point A to point B, I don't think a lot of people care about whether it was conscious during that at all. Another one is programming computers to act like humans. A lot of folks in the field actually don't think about it this way. They realize that computers can do things that humans can't, and humans can do things that computers can't. It's not enough to just say, let's copy humans. Let's actually do things slightly differently. We think back to like when Da Vinci was trying to study flight, he tried to study how birds fly. That didn't work out, right? Airplanes don't fly like how birds do. So kind of a similar thing there. And then finally, more recently in the news and the media, you might hear it as any and all decision making. So literally, like any automated decision making, people are saying that's AI right now. Not really. Like if you just have automated decision making, like if you just go and type up a program that uses like an if statement, like a conditional, for those who know what that is, like it's really, that's automated in itself, right? So that's really not an example of AI. And yet the media talks about it as if it is today. So some concrete examples of AI. So what we've seen definitions for it, what does it look like in action? This is actually really cool. This is an example of AI playing, what game is this? All right, excellent. So every time I give a talk, I like try to see if people don't know what Super Mario is. I give this talk to a lot of high schoolers, and so far all of them still know what Mario is, so we're good. So far. So what you can see here is this is not a human player, this is a computer player, right? Mario is guided essentially by these red lines. That's the decisions that the AI is figuring out how to make, right? So it's going to pick between the red lines and figure out how to get to the end of the stage. And it's amazing. It's playing way better than we could. It's crushing at this game. It's doing things that are just ridiculous. This is really cool. It like shows out. Like we never do that, right? Never. Like AI is at this level. This is wild. This is 10 years ago, by the way. This is like amazing. All right, and it gets to the end of the stage. But beyond playing games, AI can also help us, right, in actual concrete ways. So it's really cool. It can do all the game stuff. That's very concrete. But AI is also really good at helping us diagnose things that are really important to us, like skin cancer, right? It can look at images of the skin and say whether this is skin cancer or not, better than human doctors can. AI can also help. So I'm from California. We've had a lot of devastating forest fires in the last few years. AI can really help us figure out where a forest fire might start and how to best fight a forest fire. So, right, there's actual humanitarian uses of this technology. And even beyond that, you can think about just supporting different people, right? The example I really like to give is translation for civic services. And this is something that some folks here in New York City approached me with. The idea is, so let's say, so my grandma cannot speak English. She can only speak Chinese. And let's say she needs to go to DMV, she needs to upgrade or update her license. Well, the people at DMV might just speak English and she can't communicate with them, and she might not then go to DMV because she can't do this service, right? What if we have AI there to help people translate languages so that my grandma who cannot speak English can communicate with the people there who do speak English and get her new license, right? And we think about that for things like welfare, things like other programs that we might have barriers to because of language. Another one is Microsoft has released this app on the Apple App Store. It's called Seeing AI. Essentially, it's for those who are blind or visually impaired. It reads out the environment to you using AI. So AI detects things in like its visual scope, so from your phone camera, and then says, okay, these things are in front of you, right? So we can help people essentially, right? AI can be used for a lot of social good, and that's something key to remember. Because in the latter half of my talk, it's all very negative, but there are good things that we can do with AI. Another term that I'm going to use quite a bit and that you'll hear in this space is machine learning and data. So machine learning is a type of AI. Essentially, it uses data to make decisions. The most recent AI systems all use machine learning, so that's why we use the terms kind of interchangeably. So people might say, oh, AI or machine learning. It's pretty much very similar at the moment, but machine learning is a subset of AI. And how that works is very roughly, so this is like, I'm not going to go into details here, but if you're really interested, do take some AI courses here. They're very fabulous. You'll get to really learn about how these systems work. But essentially, the long and short of it is we pass in some data to a system, and in AI we call it like a model. It's kind of a model of the world. So we give some data to the model of the world, and it spits out some kind of prediction. So let's say I give it a picture of a cat, and I ask the model, is this picture of a cat? The prediction might say yes or no. And we kind of keep training this, so we give it more and more data, right? I show you a picture of a cat, the model says, let's say no, and I say no, it's actually a cat. The model will adjust itself, so then the next time I pass a picture of a cat, it might say yes. So we keep doing this for all different sorts of pictures. If I pass it a picture of a dog, I ask, is it a cat? It should say no, right? So I keep doing this, and it learns from all this data. So what's important when I design these machine learning systems? Well, these are design choices, right? What data I give it really matters. If I ask the system, is this a cat, then I never show it a picture of a cat. It's probably not going to do very well. If I show it all pictures of cats and then I show it a cheetah, it might not know what to do, right? How does it generalize, right? So the data really matters. And then what attributes of the data matter as well. So what am I looking, let's say in these images, to understand that that's a cat? So very high level, just want to give that sort of like technical depth. Within AI, there are a few different areas. Some of them are computer vision. So we talk about how computers can understand images. So things like visual recognition, seeing that that's a person's face, seeing what emotions they have. Image identification. So like you see the box here, that's a dog, that's a bike, that's a truck in the back. Figuring out what objects are in the picture. We also have things like detection. So the top one is a picture of a satellite or satellite imagery of a space that's been devastated by forest fires. So those are regions with forest fires. Here we have a picture of a retina, and that blue spot right there is actually detecting something in your eye that leads to a disease called diabetic retinopathy, which the only way you can detect it is by like having your optometrist look at the picture of your eye and say, oh, you have this one spot right here. It's really hard to do, so AI can do this really, really effectively. There's also natural language processing. So how do computers understand languages and communications, right? So we have things like translations. If you go to Google Translate, that's an example of AI. You can talk about speech recognition, so talking to like Alexa. And then there's semantic and syntactic analysis, right? You type in, this is to Grammarly, so it's like if you type in a paragraph, can it understand what you're saying? Can it like give you revisions and suggestions on what you said? Can it understand the things that you've written? There's also recommendation systems, which is how computers offer recommendations of past trends. So things like Netflix, when you finish watching a movie, it's like, like watch these other 5 movies, and then you do it, and then it's 2 a.m., and you're like, oh, I'm like gonna not sleep tonight. Or like on Twitter, like who to follow, and even Google, when you do a Google search and tries to do autocomplete, a lot of that is with AI algorithms. Fun fact about actually the Netflix thing, about now 11 years ago, 2008, they had a $1 million challenge to figure out how to give recommendations. So 11 years ago, this was like, if you could figure out how to give someone a recommendation after they watched the movie, that was worth $1 million. Like this is a hard problem to solve. And now today we just take it really for granted. And then it causes us to procrastinate. Finally, we have robotics, games, and decision making. So this one right here, someone said Watson earlier. Watson's actually the machine right in the middle. We can use AI for things like sophisticated game playing. We can use AI for things like robotics, so that's called a Sony Ibo. It's kind of like a toy-like dog that acts actually really like a dog using AI. And other things like prosthetics. So this person does not have her hand. Instead, she has a robotic hand, right? And it's hooked up to essentially her synapses. So her brain will send signals to her hand, and the AI in this piece of prosthetic will figure out what these signals are to move that robotic hand. So really, really a lot of cool applications. All right, so that was me talking actually for a long time about AI, what it is, just setting up the stage. This is the part of the talk that I find really fascinating, but also really contentious, right? This is the part of the talk where I talk about the social implications, right? How does this affect society? We talked about, yes, it has great applications. We can use it to really help people, solve crises and solve diseases. But there's also a flip side to that we have to think about. So back in 2016, there was a paper that came out from a journal called ProPublica. And these journalists were looking up this algorithm called Compass by an organization named North Point. Now, Compass is a tool that helps police officers, judges, people in the criminal justice system figure out how likely someone is to commit another crime based on past crimes. So they'll give risk scores to individuals. And what ProPublica saw was, all right, let's say Bernard Parker and Dylan Fugit, two individuals, and let's compare them. We might see the risk scores that this system gives. So Bernard has a risk score of 10, and Dylan has a low risk score of 3. And you might think, okay, well, why is this risk score so high, right? It's 10, so what could he have possibly done versus a low risk score of 3, which for them meant a prior offense of an attempted burglary. So if an attempted burglary is 3, then he must have done a ton of things with 10, right? That's what you would expect. Turns out no. Right, for Bernard, the prior offense is only 1 nonviolent resisting arrest, which for us might think, oh man, like that is way less of an offense than that. So what's going on with the risk scores there? Like, why is this so much higher than the other? They actually went beyond this. The journalists actually waited a while, and so this system actually deployed by police officers throughout the nation right now, which is really, really scary. So they're using this right now to figure out who to arrest. And the journalists went back into the wild. They figured out, okay, let's wait a few months. Let's see what sorts of subsequent offenses they make, because that would link to these risk scores. Turns out not, right? Bernard has a risk score of 10. He didn't make any subsequent offenses. Dylan has a lower risk score of 3, and he had 3 subsequent offenses of drug possession. How did this happen? Why is this system so broken this way? Turns out, as they looked at more and more of these cases, it turns out that this system gives higher risk scores to black individuals and lower risk scores to white individuals. And that's the truth, and that's what they've seen over and over and over again from the data. And it turns out that this system literally had a racial bias in it that said, I'm going to just give a higher score to all black individuals. And that's based off of the racist data that we have from policing. So this is out there right now. Police officers are using this right now. Court systems are using this to think about sentencing. This is happening, right? And we know that the bias is in there. And this company has not done anything about it. Like, they know about this. It's been 3 years now, and they're still using it. Nothing has changed. In 2016, afterwards, a really amazing book came out called Weapons of Math Destruction. This is amazing. Like, you really got to go out there and read this book. If you're, like, you don't have to be in CS, you can be in any engineering field or just any person out there to realize this is happening to all of us, right? There are a bunch of compelling case studies in here, whether that's about job recruitment, getting loans, thinking about credit scores, thinking about housing. We're using AI in these systems today. And what's really scary about it is these 3 points that Kathy talks about. So Kathy says, one of the dangers is automated decision-making at scale. Sure, if you have one police officer who's super, super racist, right, that's one person. But if you build that racism into these systems, right, and you deploy that system across the country, right, everyone has these decisions like that they're basing their decisions off of. So at scale, it can be really widespread. The second one is these systems are opaque. So you don't really know what's going on with them, right? You don't know how they're being trained, what people are looking at in order to make these decisions. And finally, there's a lack of regulation. There's just not policy on AI. There are deep consequences when these systems decide on socioeconomic resources. So if we're thinking about giving out loans, right, thinking about who to recruit into a company, right, that has big impacts on us. And really, they amplify a lot of the racial inequities that exist in society right now. So an organization or a group that looks at this a lot is the FATML conference. That stands for the Fairness, Accountability, Transparency Group in Machine Learning. And they started since 2014 to look at it. They're actually based out of here in NYU at first. So one of the things that they saw in 2016, there's a paper on this, was with words, right? You actually, right now with Google, they have this thing called word to vec, where they can make analogies between words and relate words together. It does things like if you give it man to king and then woman to what, they'll say queen. And they looked at this and, right, at the end here you have, if you put in he is to computer, the system will say she is to homemaker. And this is currently happening, it's still happening. A lot of people who use natural language processing systems use this system, and these sex biases are built in there, right? So that's still here. That's probably not a very good thing, right? Especially if you're thinking about it as reading through resumes, right? Another one, which I think is really cool, also from the conference, Google Translate. So let's say we type in Google Translate right now. If you go to the website right now, actually, I have to make a correction. A month ago, they changed this, so it's no longer, I believe they fixed this. But before a month ago, if you went to Google Translate, you type in, he is a babysitter, she is a doctor, translate to a language with gender-neutral pronouns. So let's say Turkish, right? Ober is just person, right? There's no he or she. Translate into that language, it strips off the gender pronoun. You can kind of guess what happens. If we translate from Turkish back to English and try to put these pronouns back, yeah, it'll change the pronouns. It'll say, oh, well, she's a babysitter and he's a doctor. It'll flip them. Google saw this and took them like 2 years to figure this out, to fix this system. So they did it. So I think that's one piece of optimism that, right, you can change the system. But this is really shocking, right? It's really striking. A new one actually just came out, a new paper came out a month ago. So this is about job hiring and hiring systems. So a lot of organizations, they have to go through literally thousands of resumes. They might actually use an automated system to just read the resumes and say, is this person qualified for this job? For computer science, this happens a lot. So they might actually read someone's resume. So this is a student who is a computer science PhD student. And they might look at this resume, screen through it, and say, all right, this system, tell me what career this person likely is a fit for. And the system here says teacher. Whereas the paper, they realized, well, they use the feminine gender pronoun, she. What happens if we just change that pronoun to he? That's all we do. What will happen? What will the system tell us? And surely enough, the system says software engineer. Right? These are used in hiring systems today, right now. Right? Just by changing this gender pronoun, it changes what it thinks this person should be hired as a software engineer or not. Right? These are happening. We can now move to computer vision, right? Some more examples. This is pretty wild. It really is fun. I'm not gonna lie. I don't know some personnel, but it's really messed up, right? This one is a Nikon camera. Back in the day, they figure out if you're blinking or not, right? To retake photos. Obviously, an Asian person, they said, did you blink? Like, come on. This one, obviously, is Google Photos, and it identified two black individuals in photos as gorillas, which is a racial epithet. That's really messed up. These are the biases that we have in our system. It's because a lot of people who make these systems are Asian or Black, and they don't test these things. So, and it gets worse. So, Amazon this year, or over the last few years, has been promoting a product called Amazon Recognition. This is something that they're hoping to have facial recognition for the police, so that police can use facial recognition ID. There are a lot of questions here about surveillance, or about privacy. Do we really want police to come up to us and see our faces and automatically know who we are? That's really scary. Is that a breach of privacy? And the ACLU thought about this. So they think about First Amendment rights. This is an organization that thinks a lot about privacy, human rights, and whether that's constitutional or not. They've looked at the Amazon recognition system that they've been selling to police officers, and it turns out For about 28 members of Congress, this system would inaccurately classify them as criminals. But Congress criminals. But so these are false matches. It's pretty much so these are not criminals, but it's matching them as criminals. Imagine that being out there in the field, a police officer walks up to you and it falsely thinks you're a criminal, and they arrest you there on the spot, right? What sorts of implications does that have? It turns out what's important for me when I think about these sorts of problems is this other dimension of race. It turns out that there's actually bias in this, right? The false matches are way worse for people of color than those who are white individuals. So if you're a person of color, it's more likely to deem you a criminal using this system. Amazon has not responded, and they've actually pushed back and said, oh no, this is fine, like whatever. And that's why people in the room really matter, because we have to identify that this is an issue, right? This is tied to a really, really fascinating study by Joy Boone-Winnie, who's a researcher up at MIT. It's pretty wild. You can't see her face in this photo. Essentially, Joy is a black woman who studies computer science. And she was doing an AI class where they had a facial detection project, where they had the system, and you're supposed to stand in front of it and have it detect your face, and you do some like homework assignments off of it. So as a black woman, she would move in front of this face. Like for all the other like Asian and white peers that she had, they would do it, it would detect her face, they would do their assignment, and it would be done. But then she would go in front of the system, and she would stand in front of it, and it wouldn't detect her face. It just wouldn't see that there's a face there. And in this photo, you see this. This is really, truly depressing. She took a white mask, put it over her face, and then the system said, oh, there's a face there. Right, so that's really shocking, right? That would not have, in this talk, she said, if there wasn't a black person in this room, they would never have realized that this happens in the system, right? That's why that diversity matters. So she extends this research. She's been doing this research for a long time. And at the 2018 FATML conference, she actually released a paper on looking at how well facial recognition systems work for people of different skin tones and different genders. As you might expect for lighter skinned males, 100%, right? It works really great to figure out where your face is. For lighter skinned females, it's 98%. Still pretty good. Not as good as the men for some reason, but still pretty good. But when we start talking about darker skinned faces, 94% for darker skinned males, and a shocking 79% for darker skinned females, which is what, 20% difference from lighter skinned men. So something's going on there, right? This system is not working for everyone equally. I think about this a lot because it has deep implications for us, right? I've been traveling a lot for my work, and I was going back from Canada back into the country, and they needed to take a photo of me with the automated system for me to get back into the country. For a while, I couldn't figure out where my face was. It's using these algorithms, right? Imagine if you're a black individual coming back into the country, and this system cannot figure out where your face is. There's no one else there. That system cannot take your photo. You cannot re-enter the country, right? That's the sort of level of implications that this has and impacts that it has on us. And not all is lost. After the research was finished, Joy sent out these findings to all these companies where they use facial detection systems, and IBM actually responded to it. IBM said, you know what, this is a problem. We're going to fix it. So they released a paper literally a month later, and in this paper it shows, you can't really see that down here, but the error rates are essentially, it's not 20% error rate, they've reduced it down to almost even for everyone. So they responded, it is possible to change these systems, right? We're not doomed to just say, oh, the data was bad, the systems are going to be bad. No, we can go in and tweak it. We can make it fair and equal for everyone. And what's really interesting for me, actually, is I never know this, but someone pointed this out to me. The lead researcher who did this response, who did this work and fixed the systems, was a man named Ruchir Puri. Really interesting for us because we had a student whose name is Isha Puri, and I realized this is the dad of our student Isha. Because after she went through our program to talk about, like we talked about AI and social implications, she went and talked to her dad about it, and her dad was like, okay, like, we gotta do something about this. So somehow in the grand scheme of things, the things that we've done have directly affected the work, right? So that's something that we're really proud of. Now, I wanted to end the talk on like a happy note and say, you know, everything's great, everything's solved now, everything's fine. But the story continues. This is still happening today. The policing systems are still being used by police These systems are still being used by computer vision. Amazon very notably has rejected it and said, no, there's no racial bias, things are okay. A paper actually just came out literally last night. Literally like last night, like I was going to sleep, I was finishing up my talk, and I was like, okay, things are fine, right? Kate Crawford, who is the co-founder and lead researcher at AI Now Institute, which is based here in New York, they're really, really cool to check them out. She tweeted this about the study that shows that self-driving cars are better at detecting pedestrians with lighter skin tones, right? So if we use these systems in cars, they're more likely to swerve and save white lives than black lives. What does that mean for us, right? We have to think about these things as makers of this technology. And you might think, okay, well that's fine, like, well obviously let's fix this. But professors have responded to this, and like serious CS professors have talked about this. And this is a response to one of them. The problem is, this could be true, this is in response to saying, well, a lot of black individuals are hard to identify. And this person said, that could be true. Listen, that's so racist. Listen, that's just so ridiculous. Actual CS professors think that, right? There are other papers where it says, oh, black individuals, right, it's hard to detect the differences between our faces. We know that not to be true. Hopefully the people in this room know that not to be true. But there are serious CS professors who think, no, that could be a thing. That could actually happen, right? That's ridiculous. So the person I work with here, she's a researcher at University of Washington, right? She said, I've seen a lot of people in my mentions say, oh, they don't really mean all people, black people look the same, but literally, like some CS professors have gone full way, like 0 to 100 and said, yeah, no, that's what they mean. That's why we need more diversity and inclusion in this space. We need people who don't have these terrible hot takes, right? These are people making the system right now, and that's why these systems have the biases that they do, which are completely racist and sexist. So the takeaways from my talk, data is human made. The data that we feed to these systems, we get to pick what data that is. The reason why the facial recognition system didn't work is because they fed it essentially a lot of white faces. They just didn't think about darker skin faces to feed the training system on. Data is human made. We get to pick what data goes in. The algorithms are human made. So these are the things that help us train our systems to figure out how to make them intelligent. Those are human made. These systems are all human made. So AI, as we've seen with the robots, that's not independent of humans, right? It's not just this thing over here that's objective. No, we actually bring our biases into this space. These systems are essentially systems of oppression, right? They're increasing rates of incarcerating those who are black individuals versus white individuals. They're being implemented today, right? It's still happening. They amplify human biases at scale. So if you just had one, let's say, reviewer of a job application, and they look at your jobs, right? That's one person. But if we sell these systems to literally all the companies out there, and they all use a system that says, oh, we should hire men more, right? That creates these biases across the board at scale. Who creates AI matters, right? We have these professors who just think, oh, you know, there's not a problem here, like black individuals look the same. Like we just have these people in the room, we're never going to solve these issues, right? And AI and STEM are not apolitical. There are political and social implications for us because we use these systems that do affect us at this level. And again, there's hope. We can decide what's made with AI, right? We can make better data sets like IBM did. We can do better. We can fix this. This isn't just doomed. Like, this isn't just going to inevitably happen. We can do something about it. And that really only can happen if we work across disciplines. So beyond engineering, beyond computer science, we need like the other engineers in the room. We need the social scientists. We need the policymakers. And more people of different identities in the room to create AI that really benefits all. So I talked about all the good things in the beginning of the talk. That's only possible if we all work together and we have a diverse population making this AI. What can we do? Just reading this off quickly, we can do direct research and product interventions. If you're in the room and you say, this product is directly not serving people, we have to speak up about it, right? As scientists, if we know something is wrong, we have to speak up about it. We can go through public policy routes. We can talk about it, talk to others who are working on this. We can influence decision makers by creating policy. We can fight for cultural shifts, right? Whether that's cultural in our classrooms, in our labs, in our companies, or if you're creative, right? Like if you make music, you make entertainment, right? Having, looking at the culture, changing the culture, right? To remove these stereotypes and biases. Really, it's this idea of leading from any share. I know many of you might not be computer science students, many of you might not be doing AI, but AI really is everywhere. It might affect your discipline regardless of whether it is CS. But wherever you are, right, you can make a difference. And that's like for real. Like you can really make a difference for any position you are, whether that's CEO or entry-level engineer. All right, and if you want to learn more, there's some excellent books talking about this specific topic. There's Algorithms of Oppression by Sophia Noble. This talks about racism in Google search queries. Automated Inequality, which talks about a lot of these socioeconomic systems and where it's not serving those who are poor individuals. And Artificial Intelligence, which talks about AI isn't the solution to everything. And we shouldn't take that as, we shouldn't use tech as literally the solution for all things. Some relevant orgs in the space, I'll just mention some cool ones like AI Now Institute, that's based here at NYU. They do kind of leading work on social implications. So a lot of my talk today relates to their work. Do check them out. There's other groups like Women in Machine Learning, Black in AI, Latinx in AI, Queer in AI. They're doing great work around raising these issues of identity and talking about social issues with the technology we create. All right, that's it. Thank you. I talked for literally an hour at you. I know, sorry, but thank you. Thank you.